Okay, so now we've talked about the divergence test. Basically, again, the idea is if the limit is not zero, then it diverges. Now, if the limit is zero, then maybe it converges, maybe it doesn't. We can't tell. But we know it must be zero. Otherwise, it can't converge. Okay, so if we get a result where the limit is zero, then the test is inconclusive. But if we get a non-zero result when we do the limit, then we know the series will diverge. Okay, so what we do with the divergence test is just look at the limit of the underlying sequence, the thing we're adding up. So limit as n goes to infinity of 2n over 2n minus 1. Right? And then we say to ourselves, the only thing that's going to matter is the largest power on the top, the largest power on the bottom. So that would be 2n over 2n, which would be 1. Which would be 1. Okay. And so therefore, this thing is going to converge to 1, the underlying sequence. That means if we were adding terms of it up, we'd be adding an infinite amount of 1s, which would be infinity. And so therefore, by the divergence test, this series diverges. This series diverges. Okay, let's consider a second example here. Let's consider, I guess we'll call it part B. Let's look at the series as k goes from 1 to infinity of ln of k over k squared. Okay, so we begin looking at the limit of the underlying sequence. So the limit as n goes to infinity of the ln of n over n squared. Of course, that's an infinity over infinity limit. So we apply L'Hopital's rule, take the derivative. And that would be 1 over n over the derivative of n squared, which would be 2n. Right. We simplify. That would be limit as n goes to infinity of 1 over 2n squared. Right, when you simplify that, 1 over n divided by 2 over n, or 1 over n divided by 2n will become 1 over 2n squared. And so as n goes to infinity, that is 0. So what we can say here is we can't say it diverges, but we can only say now that this test is inconclusive. Okay, this test is inconclusive. Okay, what would determine is how quickly that thing actually gets to 0. Okay, and again, there's going to be various tests that we'll be able to perform to help us with answering that question about a sequence. Okay, so these are just two quick examples with the divergence test. We're going to look at a couple others as well as we continue on. But I just want to give you these first couple of examples here so you can see the idea of how it works.